Yeah, let me know whether I'm audible or not. So in this class, we are going to solve some 30 plus very good questions on subject network analysis for your Coal India Limited CBT preparation. Okay, computer based test preparation, network analysis. Network analysis is one of the easiest subject. Yes, compared to all other subjects in electrical engineering, network analysis is one of the easiest subject. And see, most people often ask me, sir, how to save time in the exam? Not saving the time, how to manage the time. In fact, how to manage time in the CBT. That is their primary question. So some questions, no, just by looking at the options, you can pick for the answer if you get that expertise. So then, how to get that expertise? That expertise, if you get, if you practice more, right? And that to not blunt way of practicing, smart way of practicing is very important. I repeat, not blunt way of practicing, smart way of practicing is very important. Okay. Now there is a question given here. What is that question, sir? A 10 ohm resistor is connected in parallel with 15 ohm resistor. Okay. He's saying 10 ohm is connected in parallel with how much? 15 ohm. This combination is in series with a 12 ohm resistor. Okay, this is a 12 ohm. Now the equivalent resistance will be, you may be thinking, sir, you are taking very easy questions. Yes, this level of questions only will be asked in your CIL CBT. I can discuss this subject to any depth. I repeat, I can discuss this subject to any depth. But see, applicability is very important. If I'm discussing a series RLC circuit with DC input with different values of zeta, and I'm drawing all those waveforms, it is just a waste of time. So people are asking, sir, HPCL JO electrical results when going to be announced? HPCL JO results are not yet announced. I don't know, actually. I don't know, frankly to speak. Okay, soon you will be getting, why? Because people already started preparing for interview. Okay, many students started preparing for interview, so maybe soon the result will be out. Okay, now answer this. These two are in parallel combination of resistances. Formula is what? R1 R2 by R1 plus R2. If I take if you designate them as R1 R2, and this is going to be R3, this is plus R3. How much it is? 150 divided by 25 plus 12. So 25 6 it is. Yes, 25 4 is 100. One more 25 125. One more 25 150. How much it is? Simply 18 ohms. Option is C. Option is C. C for Chennai. Yes, somebody given Lakshmi is no. Kumar. Who is that? Some Kumar given the answer. Yes, Kumar given the answer, right? So result will be announced, man. Don't waste your valuable time. Read the question, try to solve on your own. I'm expecting an answer from you. There are 8 guys in this live session as of now. Please, all of you 8 try to answer in the chat box. What is saying? Two resistors, R1 is equal to 10 ohm, R2 is equal to 20 ohm are connected in series order to 30 volts. Okay, there is a 30 volts of DC supply. Yes, there is plus minus 30 volts of DC supply. So this one R1 R2 is connected. This is R1, this is R2, this is a 10 ohm, this is a 20 ohm. One simple thing is in series current is same. Right? What will get divided? Voltage will get divided. In series current is same, voltage will get divided. Now 30 volts. Okay, now how much is the voltage here? This voltage will be 10, this voltage will be 20. Sir, how do you know that? 30 volts among 30 ohms, every 1 ohm will get 1 volt. Yeah, 30 divided by 30. People given D and C as the options, two different answers. We will check. Okay, now power is equal to V square or by V square by R. P1 is equal to I square into R1. Okay, P2 is equal to I square into R2. Both are having current of I only. The reason is series circuit. I square get cancelled. P1 by P2 is simply is equal to R1 by R2. How much is resistance R1? 10. Resistance R2 is 30. That is equal to simply 1 by 3. Option is A for apple. People given D, C, B, but option is A. Oh, sorry, it is 20, right? It is 20. It's my mistake. It's my mistake. It is 20. Option is 1 by 2. 1 by 2. 1 by 2 it is, please. It is option C. I taken it as 30 ohms. No, it is 20. Yeah, power in the resistance 1 is I square into R1. Power in resistance 2 is I square into R2. Why same current? Both are in series. If both are in series, I square R1 by I square R2, I square will get cancelled. P1 by P2 is equal to R1 by R2. So R1 is 10, R2 is 20. So that is 1 by 2. From here, there is some conclusion. In a series circuit, P is directly proportional to R. In a series circuit, please. In a series circuit. In a series circuit with different series resistances, right? Yes or not? See, some people committed mistake. Who is this? Rock given option as D, and Kumar given as B. It's neither D nor B. It is option C. C for Chennai. Right? Try this question, all of you, on the same grounds. Try that question, please, all of you. Yes, I am giving you some 1 minute of time. Try that answer, please, all of you. Yes. Answer, please. What is saying? A circuit consists of 4 resistors, 5, 10, 20, 30 connected in parallel. Okay. 5 ohms. Yes. 10 ohms. Yes. 20 ohms. Yes. 30 ohms are connected in parallel, supplied to a DC voltage source of 100 volts. Okay. Which resistor among the 4 resistors in the above circuit has a least value of current? RAR. V is equal to IR. So from this one, I is equal to V by R. The highest value of resistance will give you least value of current. Obviously, 30 ohm. Is this is a question? Damn simple question. 30 ohms. So can you solve in V square? Mr. Rock is asking to solve this question in V square. Yes, let's do. Let's do. This P1 is equal to V square. 10 is the volts. 10 volts. V square by R. P2 is equal to how much, Mr. Rock? V square by R. Now take this ratio. 10 square by 10, 110 is left. 20 square by 20, 120 is left. So 10 divided by 20. That is also 1 by 2. Na? Mr. Rock, observe it. The previous question you asked me to solve by using V square by R. Yeah, V square, voltage is 10 volts by R. V square by R. 10 square by 10, 110 is left in the numerator. 20 square by 20, 120 is left in the denominator. 10 divided by 20, 1 by 2 is the answer. Please acknowledge me whether you understood that one or not. Right? Yeah, fine, Mr. Rock. Come here. Now, the resistance which is having the highest value of resistance will be drawing least value of current. Highest current is this, lowest current is this. Answer is A, option here. That is the question. Okay. Now try this. Determine the capacitive reactance. What is there in this plan? Capacitive reactance XC is equal to 1 by 2 pi FC. Its units are ohms. Now from this one, XC is equal to 1 by 2 pi F is 50 into how much is capacitance C? Capacitance C is given as 60 microfarads. So you know one thing, sir, this was simple. Why you taken this question? Calculation speed is also very important in the examination. Okay, you must be good at the calculation. 10 to the power of 6 divided by, so 100, 10 cube, 100, 10 square, 10 cube, 10 cube into 3.14 something into 5 into 6. So this is a 10 cube divided by 30. 30 3 times 90 means almost it is 100. Almost it is 100. Answer will be near to 100, near to 10. Answer will be near to 10, but not there. No. Check my calculation once if I committed any mistake. 2 into 50 is 100, 10 square. 60 in 60 I taken 110. Okay, 10 cube. Okay, then I'm left with pi into 6 into 5. 6 into 5 is 30. 33 times 90, right? 90 point something. So 1000 divided by approximately 100 if I take, answer should be in the range of 10. Yes, option is B. Any mistake I committed here? X is equal to 1 by omega c, 2 pi F into C. I'm correct only, na? Answer should be near to 10, man. Why 53.1? People are saying D. Let me use calculator, but to the best of my knowledge, answer should be near to 10. Near to 10. Maybe options are not given in correct way. That's why I'm using calculator. But do remember in your examination, calculator is not allowed. Okay, 3.14 into 30, 94.2. 1000 divided by 94.2. Yeah, 10.61 is the answer, man. No option. No option. XC is equal to 1 by omega c. Omega is 2 pi f. 2 pi f is 50 into c is 60 micro. 60 micro. Very clear. No data. No data is wrong. So pi I'm keeping 10 cube. Why I wrote 10 cube? Okay, okay. Here 10 is there. Sir, 50 into 200. 100. In this 10 I taken. 1000 gone. Now pi is there. 5 is there. 6 is there. Pi is 3.14. 5 is there. 6 is there. This is 30. 30 into 3, almost 90. Okay. 10 cube times gone. You are left with 10 cube. 10 cube divided by around 90 will be, answer will be 10 point something. 10 point something. Options are not matching. You people are giving option as B, option as D. Yeah. Check Mr. Mandal. Okay. Mr. Mandal and this S21 underscore. Sir, can you teach live classes for PGCIL? Yes, I teach for all the modules at YourPedia. Okay. Now see, this question I taken for the purpose of calculation, and you just catch how I calculated to save your valuable time. Answer is not there. Answer is not there as per me. Okay, I don't know how you're getting option as B or B. Check your calculation once. Check your calculation once. I checked with my calculator also. Answer is not there in the given options. Okay. Yeah. Try this. Determine the power dissipated in watts by the 25 ohms resistance. Yes, he's asking the power dissipation in this resistance in the circuit given below. Yes, he's asking about the power. Okay, now only one step. People may think a lot like what to do, sir, how to do, sir. Nothing. Just convert this voltage source in series with resistance, current source in series with resistance. This current source in series with resistance as voltage source in current source in parallel with resistance as voltage source in series with resistance. Source transformation. This is 50 plus minus 50. This is a 10 ohm, right? This is 25 ohm, right? So this is, sorry, let me take this way only. This is 5 and this will be 50. This will be 50. If you do this step, answer directly you can conclude without any yes, very good. S21, answer is 0. Answer is 0. Very good. Answer is 0. Option is A. Who else given the answer? S21 only given the answer as A. No, come on, Mr. Jalebi. Okay, Jalebi 007. Previous question, huh? Previous question not matching, man. See, XC is equal to 1 by 2 pi. 2 pi. F is 50. C is 60 into 10 to the power of minus 6, man. XC is equal to, let's take 10 to the power of minus 6 to upside. 2 into 50, 100. 100. In the 60, let's take 1. Then you are left with the pi into 5 into 6, 30. Right? So this 10 cube times gone. This pi into 30, this is 3 point something. 30 into 3 point something will be 90 something. 1000 divided by 90 something will be approximately around 10 you have to get. But none of the option is there, man. Why you guys are saying option as B? How you got B? Check with your calculator once. Or if I committed any mistake, please let me know. Okay, how the answer is option B? How the answer is option B, please. See, most of you are telling the answer as B, but I am not getting as B. Okay. Yeah. Hello. I'm waiting for you, man. I'm waiting for you. Yes. So calculation mistake from my side. No, man. Come on, here. See, I'll do this. I'll do this. Again, I'm doing here. Observe, observe. XC is equal to 1 by 2 pi F 50. C is 60 into 10 to the power of minus 6. Okay. Let me do carefully. 10 to the power of 6 divided by, yes, 50 into 200 I taken. Any objection? Okay, 1 5 extra I taken. Sorry, yeah. 1 5 extra I taken. Okay. Pi into 60 it is. Pi into 60. Yes. Yes, yes. Mistake from my side. And 110 you give here. 10 to the power of 6 divided by 1000 into pi into 6. What the mistake I committed is 50 into 2 I taken 100. Again I consider that 5. Again I consider that 5. That was mistake. That was mistake. This is a 10 cube times 1000 divided by, so how much it is? 3 point something into 6, around 20 I will be getting, around 20. So around 50 I have to get, around 50 I have to get, but all options are very nearby, so you have to divide it. Okay, option B only correct, option B only correct. Yeah, yes, correct only, correct, 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 correct. Leave it off. Now here answer is 0. Why? Convert this current source in parallel with resistance as voltage source in series with resistance. Current, this one also, no, same voltage. Here the voltage is same. Then how much is the current that is flowing? 0 amperes. Na? I is equal to voltage 50 minus 50. Yeah, current is equal to voltage difference divided by total resistance. How much it is? 10 plus 25 plus 5. 0 by anything is what? 0. If current is 0, the power in 25 ohms is equal to I square into 25. That is equal to 0 watts. Option is A for apple. Right? Most of you given correct. Try this question, please. All of you try this question. What is saying? Not required. Not required. This something is missing in that. Okay. Try this, please. Try this question, please. All of you. Try that question, please. Yes. What is saying in the circuit given below? I is equal to 1 ampere. Okay. I is equal to 1 ampere. This current, this fellow given. This is 1 ampere. Okay. Accepted. IS is for IS is equal to 0. Okay, he is saying this value is equal to 0, then why given? Okay, I is equal to 1 ampere for is is equal to 0. What is the value of I for is is equal to 2 amperes? Okay, he's asking, brother, let's take this one as 2 amperes. Let's take this one as 2 amperes. This one has 1 ohm, this one has 1 ohm, this one has 1 ohm, and this voltage is not given. This voltage is not given. Now let's find this voltage now. Now, if this is 1 ampere, no current here. This current is also 1 ampere, na? Sir, how do you know that current is 1 ampere? KCL. Now, write the KCL here. This current is 0. Why? That fellow mentioned in the first case, IS is 0. Now, how much current is going this way? 1 ampere. This way, 0. Therefore, that should come from this way only, na? Yes or not? See, first case, this is the circuit, man, in the first case. Good question, man. Good question. Good question. This is okay. All of you must try to understand. Plus minus V volt. We don't know. We have to calculate it. This is 1 ohm. This current is 1 ampere. Therefore, this current should be 1 ampere. Now, therefore, this current is 1 ampere. Now, if that current is 111 like that, this is anyhow 1 ohm. This is plus minus 1 volt. This is plus minus 1 volt. Let's write the KVL for this loop. What you get? Minus V. I'm starting here. Minus V. Go forward. Plus 1. Go forward. Plus 1 is equal to 0. So from this one, V is equal to 2 volts you get. So from this one, what? V is equal to 2. Yes, I know V is equal to 2 volts, please, not amperes. V is equal to 2 volts. Now, this is 1. This is 1. Now, he's asking this current. He's asking this current. Right? Now, very simple way I'll solve. Very simple way I'll solve. First of all, till here, all of you understood or not? Please acknowledge. Some people given me the answer as 3 amperes. Option as C, they are saying, let me do. Okay. This S21 given answer as 3 amperes. Let me do. Till here clear? Up to here clear? How we got the voltage as 2 volts? Now, I don't know in what way you solved. I always prefer current distribution method. This is 2 amperes. This is I. Then how much is this current? This current will be 2 minus I according to KCL. 2 I is going. This will be 2 minus I. Right? That is 2 minus I. Okay. Then this voltage is 2 divided by 1. How much is this current? This current is 2 amperes. Yes, this current is 2 amperes. Sir, how do you know that this current is 2 amperes? This voltage, these two are parallel. This voltage is 2 divided by 1 is 2 amperes. Now, how much is this voltage? This voltage is 2 volts. Anyhow, we know this one. Now, how much is this voltage? This voltage is I. How do you know, sir? This current is I, this resistance is 1. 1 into I is I. Voltage is I volt. Voltage is I volt. Voltage is equal to current into resistance. Current is I. Resistance is 1. 1 into I is I. This voltage is 2 minus I. Now this voltage is 2 volts. Now write the KVL for this loop. Minus 2 minus 2 minus I. I'm writing minus 2 minus I plus I is equal to 0. Plus I is equal to 0. Minus 2 plus I is equal to 0. So 2I is equal to 4. I is equal to simply 2 amperes. I is equal to 2 amperes, man. Mr. S21. I is equal to 2 amperes, not 3 amperes. Yes. Only that person S21 is replying me in the chat box. Remaining guys are not at all. They are replying or not doing anything. Right? Yes. Okay. Let's go to the next question. It's asking, that is a question? Without pen paper, you can answer that question. Okay. 30 seconds is the time I'm giving. 30 seconds. Yes, people are saying option as C. Jalebi saying C. S21 saying C. Okay, what is asking? Determine the average value of an alternating current. Okay, I average for an alternating current. For a full wave, it is zero actually to speak. For full wave, it is zero, but in the options, zero is not there. Yeah, if you take any alternating quantity, AC quantity, positive half cycle exactly equal to negative half cycle. For a full wave, 0 to T by 2 to T, if you take the average, positive and negative, average means area by time. See, what is average? So average is equal to area by time. Now area equal positive, equal negative half cycles are there. Zero it will be. Zero it will be. Average is equal to area by time. But zero is not there in the options. If zero is there in the option, pakka you have to tick for zero. That's the reason why I selected this question. As zero is not there, what is full wave rectified average? Full wave rectified means this positive negative half cycle also we'll take it as positive half cycle. We rectify this. Now for this one, the average will be 2 im by pi, 2 im by pi, 2 into, again when the peak value of 10, 2 into 10 divided by 3.14 something, so 20 divided by 3.14 something, right? So 6 3 is nearby, 3 6 nearby, 6 point something. It is not 14, it is not 10, it is not this much less. Option is 6.37, option is C. Okay, good, good. S21, Jalebi, and Mr. Mandal, 3 people given the answer. Good, good. Let's go to the next question. Let's go to the next question. Okay, good question. This is also good question. On powers, it is on powers. It is. Do it, please, all of you. Yes. Answer, please. Yeah, just a minute. Yes. Answer. What is saying? Two incandescent bulbs rated respectively as P1 and P2 for operation at a specified mains voltage are connected in series across the mains as shown in figure. Okay, both are in series. The total power supplied by mains to the bulbs are, both are in series, na? Both are in series. See, what is the power taken by first one? That is I1 square, I square into R1, right? So P2 will be I square into R2. I square into R2. Then he's asking what is the total power taken. It is not P1 plus P2. When it is P1 plus P2, if both are getting same voltage, then it is P1 plus P2. Otherwise, it is not. Otherwise, it is not. Now, P1 plus P2 means not that P1, P2. Now, the power taken by this one is P1, which is equal to I1 square plus R1. Now, if I add these two, what I'm going to get? See, R will do in different way. Will do in different way. So, power taken by first bulb is I square R1. Second bulb is I square R2. But that option is not there. In terms of P1, P2, it is there. What is P1? P1 is equal to V square by R1. So from this one, R1 is equal to what? V square by P1, right? From this, P2 is equal to what? V square by R2. From this one, R2 is equal to V square by P2, right? Now, yes or not? Yes. Now, what is the voltage here? What is the voltage here? V1. What is the voltage here? V1. What is V1? V into R1 by R1 plus R2. What is the voltage here? V2. What is that? V into R2 by R1 plus R2. Right? Now, let's apply the formula V square by R. Yes. First power is V square by R1. Second power is V2 square by R2. Right? So V1, let's keep it as V1 only. Then how much is R1 we got? Yeah, we kept V1 as V1 only. V1 square by R1, how much we got? V square by P1, right? But this way also it is not getting tallied. Means, yeah, answer we can get, but the simplest and short way I'm thinking about is, okay, what is V1? Let's write V1 this way. Let's write V1 also. We got V1 also. Let's write this way. What is V1? V1 is V into, means V square into R1 square by R1 plus R2 whole square into 1 by R1. Now, this gone. Plus V square into R2 by, yes, R2 by R1 plus R2 whole square into 1 by R2, right? Yes or not? R2 square it is, please. R2 square. R2 gone. Now, how much I am left with? Let me take this side, this side. Now, what we are having? V square into R1 by R1 plus R2 plus V square into R2 by R1 plus R2. But equation is getting satisfied. What is that? No. No. Not this way, not this way. Okay. First one is P1 is equal to I square into R1 man. Okay, let's get this way. I square into R1 plus I square into R2. Okay. What is I? What is I? I is equal to V by R1 plus R2. Accepted. Let's replace this one with R1. Let's replace this one with R2 man. R1 and R2, right? Now, done. V by R1 plus R2 whole square into R1 plus V by R1 plus R2 whole square into R2, right? So from this one, if I take V square common, what I'm going to get? V square by R1 plus R2 I'm going to left with. Yes, V square if I take common, R1 by R1 plus R2 whole square plus R2 by R1 plus R2 whole square. Then R1 plus R2 by R1 plus R2 whole square will be, one square will get cancelled. So this is the total P. Yes. Yeah, from this one we can easily get. What is that? Total P is equal to what? V square by R1 plus R2. Yes. From the options you can check. Which one is correct. Okay. P1. What is P1? P1 is yes. P1 is I square into R1. P2 is I square, same. I square into R2 by, yes, P1 plus P2. What is that? I square R1 plus I square R2. So it will get cancelled. I square will get cancelled. You are left with what? R1 R2 by R1 plus R2. But it is not valid. Anywhere I committed any mistake? Any mistake I committed in the calculation? Come on, man. Let's take a new page and do there. There is a bulb whose resistance is R1, its power rating is P1. Another bulb whose resistance is R2, its power rating is P2. So this is supplied with a common voltage of P. Okay. Now, what is P1? P1 is the rating, power rating of, see, you guys are giving the option as A, but there should be a proper derivation, otherwise it is useless. Proper derivation. P1 is equal to V square by R1, man. V square by R1 means P1 is the rating. Okay. One should understand the given question carefully, that two incandescent bulbs rated, P1 is the rated power. Means what? Whenever rated voltage of V is given, I repeat, whenever rated voltage of V is given, then it is going to take the power of P1. But here rated voltage is not given. For both combinedly V is given. Now V is divided into two parts. V is divided into two parts. Okay. Now P2 is the rated power of that bulb 2. What is that? V square by R2. Okay. Now this total V is not given to R1, not given to R2, but its division is given. Means how much is this voltage? This voltage is V1, this voltage is V2. Now total power is equal to V1 square by R1 I can take, plus V2 square by R2 I can take. Yes. Now from this one, what is R1? R1 is equal to, yes, V square by P1. R2 is equal to V square by P2 I get. Right? Now V1 square, but V1, V2 ratios we don't know. If we take, it is getting cancelled. But these are the rated powers, not the present powers. Those are the rated powers, but not present powers. Present power is not P1, not P2. This is the present power. This is the present power. Okay. V1 we don't know. V1 we don't know. V2 we don't know. But V1, V2 we can get in the form of, what is V1? What is V1? V1 is equal to V into R1 by R1 plus R2. I can take this way. So V2 is equal to V into R2 by R1 plus R2 we get. Let us put there and see whether it is able to converge or not. What we are going to get? R1 square, V square, V1 square, na? V square, so V1 square, V square, R1 square, this is R2 square, V2 square, V square, R2 square, this is square. So from that total V square, if I take common, okay, V square I can take common, that's fine. I taken V square common. Now in the numerator R1 square, R1 by R1 plus R2. Yeah, we got it as this way, na? V square by R1 plus R2 we got it. For this one, this much derivation need not to do. This much derivation we need not to do. Because now let us check option 1. From options, let's try. P1, P2 by P1 plus P2 is the first option that is given. Let's try what happened here. What is the P1 in terms of V1 square by R1? P2 is V2 square by R2. Let's try. What is this? V1 square by R1 plus V2 square by R2. Yes, right. Now V1 square into V2 square by R1 R2 by V1 square R1 plus R2 plus V2 square R1 by R1 R2 is gone, but not matching. No, not matching. Why? V1 square into V2 square by V1 square R2 plus V2 square R1 we have. Let us substitute further. Let us substitute further. Something is missing in the question, that is those powers should not be mentioned as rated powers. Sir, please solve those questions before class begins so students don't see confusion face between. See, Miss RP989. The only point here is there is some confusion in the question itself that that power should not be given as rated power. Okay, let us skip that question for timing. Let's go to the next question. Okay, generally that is a previously asked question. We with this much experience need not to solve in prayer to the best of your knowledge. You need not to solve. The only point was there here is the fellow given as P1 and P2 as the rated powers. Rated powers means when if you apply the full voltage V, then that power. So P1 is equal to V square by R1, not V1 square by R1. Okay, that is the point. Right? Okay, let us see it in the last at least, no problem. An inductor connected in series with a DC source in a closed circuit will behave in steady state as, see here some 4 points I wanted to give you. Inductor, okay, inductor, this is a capacitor. We have 4 states or 4 points. One is T is equal to 0. T is equal to 0 or starting. T is equal to 0 or starting or initially, not starting, we are not starting any bike. Initially, this is initially. Okay, initially inductor behaves as open circuit. If you remember this one, remaining all you will be able to remember. Okay, I know answer this one is very simple, but let's understand. If you are able to remember, understand this one, remaining you can easily remember. Why initially inductor behaves as, see, first one is inductor. Why initially inductor behaves as open circuit? Why? Because inductor does not allow sudden change in its current. I repeat, inductor does not allow sudden change in its current. Sir, why inductor does not allow sudden change in its current? Why inductor does not allow sudden change in its current? Energy of inductor is equal to half L I square. Energy of inductor is directly proportional to current. So in this world, no energy can change suddenly. Suddenly, energy cannot change. So this is not possible. This is also not possible. Inductor, please. Inductor. Why? If you just look at your fan in your room, if you switch it off, it will take some time to stop. It is not going to stop all of a sudden. It will take some time to stop. Why? What is the reason? What is the reason? The reason is it is already having some stored mechanical energy in the rotor body. Due to that reason, it will take some time. That's why, as it is not allowing sudden change of current, people will misunderstand the statement. Inductor does not allow sudden change in its current, but inductor will allow gradual change in current. See, what is sudden change? Up to t is equal to 0, current is 0. Now, suddenly, if you want 4 amperes, this is not possible. This is not possible. In inductor, in resistor, it is possible. Up to t is equal to 0, current is 0. Now, from there, gradually it is reaching to 4 amperes. 4 amperes. This is accepted. This is sudden change, which is not accepted. Okay. Then, at steady state, steady state means t is equal to infinity. At t is equal to infinity, steady state, inductor behaves as short circuit. Inductor behaves as short circuit, and the current through inductor is constant. Current through inductor is constant. Right? Now, is asking, will behave in steady state as it's not open circuit. We know that it is short circuit, and current is in a short circuit, current is constant. Okay, it is not resistance, it is not voltage source. Constant current means current source. Constant current means what? Current source. Right? Constant current means what? Current source. Okay. Next, try to answer that question, please. Try to answer that question, all of you. See, I'm giving you 1 minute of time. Try to answer. Yes, please. I'm waiting. What is saying? In the circuit shown below, the steady state is attained with the S open. Means he's saying that switch is opened and the steady state is achieved. Yes. Switch is open, steady state is achieved. At steady state, capacitor behaves as open circuit. Capacitor behaves as open circuit. At steady state, yes, at steady state, capacitor behaves as open circuit, which is exactly opposite to inductance. Inductance behaves as short circuit. Now, let me take up. This is the current source 3 amperes, okay, and this is 1 ohm, and this is the current I. Yes, this is 1 ohm, and this switch is opened till t is equal to 0. Means this is not there, this is coming into picture at t is equal to 0, or from t is equal to 0 onwards, which is called as t is equal to 0 plus, right? Now this is opened, no current here this way, this total 3 amperes will go. What is this voltage? 3 volts. Now let's take this one as voltage across capacitor at 0 minus, what 0 minus? Before closing the switch, before closing the switch, right? Now how much is the voltage? Write the KVL. Vc of 0 minus is equal to 3 volts. If I write the KVL, these are parallel, na 3 volts, 3 volts. Why? Because this current is 0 amperes. Why this is 0 amperes? This fellow is open circuit. Therefore, this is plus minus 0 volts. 0 volts. Now, at t is equal to 0 plus, at t is equal to 0, switch is closed, but at t is equal to 0 plus, we all know that capacitor does not allow sudden change of voltage. Capacitor does not allow sudden change of voltage. Now this is current source, and I'm not writing those values. I'm least bothered. Okay, this is 1. Now this capacitor is having initial voltage of how much? This is of 3 volts. Now this switch is closed, we have one more resistance here. Now what is the value of current I at t is equal to 0 plus? Is asking this current I. Now I have to write these values, otherwise I won't get the answer. 3 amperes, this is I, this is 1 ohm, this is 1 farad, but let's take it as 3 volts. Now at t is equal to 0 plus, this is going to behave like 3 volts, right? Now if this is 3 volt, these two are parallel. Now this current is 3 amperes. No, this current is 3 amperes. This current is 3 amperes. Okay. Now this current is 3 amperes. Okay. Now let's write. I wanted to find this. This is 3 amperes. This current we don't know, and let us take yes. This is I. Okay, I want this current. This voltage is how much is this resistance? 1 ohm. Yeah, this is I volt minus I. I'm writing KVL minus I. Okay, this is 3. This current is 3 minus I according to current distribution. Okay, this is 3. This is I. This is 3 minus I. So this voltage is plus minus 3 minus I. Okay, minus I plus 3 minus I plus 3 volts. I'm completing not required to V. I'm completing closed path this way. This way I'm completing the closed path. This current is I given by him. This current is 3. We know that this current source. This current is 3 minus I according to KCL. 3 is coming, I is leaving. Remaining 3 minus I should go, right? So 2I plus 6 is equal to 0. Minus 2I plus 6, sorry. Minus 2I plus 6 is equal to 0. 2I is equal to 6. So from this, I is equal to 3 amperes. I is equal to how much? 3 amperes. This is 3 amperes. I is equal to 3. Option is C. Good. Some of you solved 3 amperes. Good. S21 solved. Okay. Only S21 solved. What about others? What about others? No one solved. Right? Understood this question or not? See, powerful technique is current distribution. 3 amperes, I ampere, 3 minus I. Just write the KVL. Because, and this is at t is equal to 0 plus only. He is asked the current at t is equal to 0 plus only. At a steady state, again, it is different. Second steady state, it is going to reach steady state again. At second steady state, it is different. Okay. Yeah. Look at this question. That question P1, P2 question for sure will solve. We are not going to leave it. See, class is about learning. It's not mugging. Okay. Somebody given some suggestion. It's valuable suggestion like, sir, you solved before. No, I'm not going to do that. Because this is a platform where we open our thoughts. Okay. We'll verify where the mistake we are committing. Okay. You also will add your thought in my thought. So getting confused, coming out of it, getting some good conclusion, these are the parts of learning. Okay, nothing wrong with it. All the relationships what we taken are perfectly correct. In the previous question, we will solve it for sure. Okay, try this question. After this, we'll go back there. Please try this. I think I'm blocking your frame. Okay, please do it. Please do it. Try this question, all of you. Yes. So I'm giving you 1 minute of time. In that already 50% of the time is done. For the given circuit shown in the figure below, the initial inductor current and the voltage across the capacitor are zero. Means that fellow given initially, what is saying in the given circuit, okay, below, the initial inductor current and the voltage across capacitor are zero. Okay, both are zeros. This is not having any voltage initially. This is not carrying any current. Okay, accepted. Zero and 0 and 2. Sorry. Okay, he's saying this is 2 ampere. Okay, both are not 0 and 2 respectively. When the switch S is closed at t is equal to 0, the values of V and dV by dt respectively are. Is asking V and dV by dt at t is equal to 0. At t is equal to 0 means two things are very important here. So capacitor, as it does not allow sudden change of voltage, this voltage still remain as 0 plus. In fact, we have to speak not 0, at 0 plus. Voltage will remain same. See, Vc of 0 minus is equal to Vc of 0 is equal to Vc of 0 plus for a capacitor. Current for inductor is IL of 0 minus is equal to IL of 0 is equal to IL of 0 plus. 0 plus. It is not going to change. It is not going to change. Now V should be 0, right? V should be 0. Why it is 2? Now, as it is not changing sudden change of voltage, initially voltage across capacitor is 0, right? If this is 0, this is parallel to this, this is parallel to this. Now, what is V? This parallel, no? What is this? Parallel. But here, question itself seems wrong. No, correct only, correct. No, nothing wrong. Parallel, na? This voltage is V. This voltage is V. This voltage is also V. How much it is? 0. If this is 0, this should be 0. This voltage is 0. This voltage is also 0, right? 0, right? Why it is 2 comma minus 4? People given 2 comma minus 4. I don't know, they remembered. Current is 0, sir, not the voltage. Current is 0, na? Inductor current, yes. Inductor current is 0. Sorry, man. I taken in reverse. Just a minute. Okay, this is okay. This is IL of 0 plus. This current is 0 amperes. Okay, this current is 0 amperes. This voltage is 2 volts. Yeah, as capacitor does not allow sudden change of voltage, this is going to be the same 2 volts. This voltage, same voltage is going to appear across this resistance. Same voltage is going to appear across that resistance. Correct. Capacitor voltage is given 2 volts. Yes, correct. I taken it. Now this is 2 volts. Now, if this is 2 volts, 2 divided by 0.25, how much will be the current? 2 divided by 0.25. How much is this current? This current, IR of 0 plus is equal to V is 2 divided by 0.25. How much it is? 20 divided by 2.5. 20 divided by 2.5. 2.5 will be 8 amperes. This current is 8 amperes. This current is what? 8 amperes. Just I found that current. Now, what is asking? dV by dt. If you want dV by dt, IC, from IC you will get IC is equal to C dVc by dt. Okay, appropriate formula we have to take. Now, this current we know. This current is 0 because that is not going to change. Now, if I know this current, I can get this current also, na? Yes. Now, according to KCL, yes, according to KCL, tell me, IC, I'm writing all the currents as leaving. IC, capacitor current, plus all are leaving, I'm taking. Inductor current plus IR, all are equal to 0. So, IC is equal to minus IR. IR I taken downside, that is equal to minus 8 amperes. Right? IC is equal to C. How much is C? 2 dVc by dt. 2 minus 4, it is got cancelled. dVc by dt is equal to minus 4 volt per seconds. 2 comma minus 4. Good. One person give me the answer. Who's that? S21. He given the answer. Capacitor leaving current means negative sign. No, see, first of all, for capacitor, no sign of the current he given. We are assuming these current signs. Okay. Does he given current sign for capacitance? No. Only he, see, all are passive elements, na? All are passive elements. We assume that all currents are leaving, no issues, right? Yes, 2 comma minus 4, right? So let's go to this. Okay, this unfinished task is making me bother. Okay, so resistance is R1, this resistance is R2. Tell me, total power is equal to V square by total resistance. I can take V square by total resistance. Yes. What is total resistance? V square by R1 plus R2 is the total resistance. Done. R1 plus R2 is the total resistance. Okay. Now, P1 is equal to V square by R1. So from this one, R1 is equal to V square by P1. Now it will converge. Okay. Now, same way, P2 is equal to V square by R2. So from this one, R2 is equal to V square by P2. None of the things are wrong. Yes. See, unnecessary things we did. We taken the formulas or the methods which are not necessary for us. I taken Pt is equal to P1 plus P2, P1 plus P2. Instead, if you take this way, it will converge, it seems. Yeah, it will converge. Now, come on here. From this one, Pt is equal to, these equations we already taken previously. In the very beginning itself, we taken these equations. I'll show you, right? So let me little down. Yeah, V square by R1 is what? V square by P1 plus R2 is what? V square by P2. Now let's take V square common. 1 by P1 plus 1 by P2. So Pt is equal to P1 P2 by P1 plus P2. So instead of going this way, see, I'll tell you, if I directly give this method to you, it's like I mugged something. Okay, but we did a lot of things. Nowhere we did anything wrong. See, let's go to this page. Yeah, correct on, P1 is equal to V square by R1. We wrote V square by R1. We wrote P2 is equal to V square by R2. We got R1. We got R2. Right? What we have to do here, once we got R1 and R2, what we missed here is, instead of that, we went in different direction. Like I taken extra variables like V1 and V2, voltage across R1 as V1, R2 as V2, due to which our equation got satisfied. V square is equal to V square. That way we got. Instead of that, very simply, total resistance RT is equal to R1 plus R2. Yes, sir. And Pt is equal to V square by RT. If I did this, answer is done. Anyhow, we got it. Observe this one, please. Okay. Yes. Let us solve this question, please, all of you. Yes, good question. This is also good question. Try to solve. Yes. Answer, please. Yeah, that's why, see, voltage will get divided in series. That's the reason why I also unnecessarily made. So here, voltage got divided. Who told that voltage is not divided? But here, what we did, P1, that's what I'm saying. Na? P1 is the rating. P1 is the rating. Okay, it's not taking the total power P1 now. P1 is the rating. When total voltage is applied, that fellow is going to take this power. That's why he mentioned very clearly the rated powers. See, the incandescent bulbs rated respectively P1, P2 for operation at a specified mains voltage are connected in series across them as shown in figure. What does he mean is, whenever total voltage of V you apply and it is its resistance is R1, now this is consuming a power of P1. Okay, when total voltage V you apply, okay, its resistance is R2, now it is consuming P2. Now what he did, both he connected in series, no more this voltage is V, this is V1, this is V2. Now this one is coming taking how much power? Now that is already added here. Why? Because now no more simple resistance, total resistance is considering. Now see, this is from, see, V is the total voltage, not the voltage across R1, not the voltage across R2, total voltage. Okay, now total resistance I considered here. That's the reason. We got, up to here we got, even if you think, up to here we got. 2 times we got up to there. Yeah, we got here itself, this one. From here, what I missed is, PT we got V square. Previously, when the bulb 1 itself is connected, V square by R1, that is its P1. When bulb 2 is connected, V square by R2, that it is P2. Now, total resistance is connected. What is R1? R1, V square by P1. What is R2? V square by P2. Okay? Yes. S21. You understood that concept or not? Right? Yeah. In the network shown below, it is given that V is equal to 1 volt. Okay. This is 1 volt, right? And dV by dt is minus 10 volts per second at a time t, where t is the time after the switch S is closed. Okay. What is the value of C? He is asking for the capacitance C. If this is 1 volt, this current is 1 ampere, man. This current is 1 ampere. This current we don't know. Okay. The switch is closed at t is equal to 0. That is also fine. But extra information that fellow given is IC. Yes, IC is equal to C dV by dt. IC I don't know. C is how much? We don't know. dV by dt is how much? Minus 10. Okay. This way one thing is there. 1 volt. Okay. Now he's asking for the value of capacitance C. Fine. That voltage we know. This current we know. And let's take this current as IC at 0 plus. Now, what is this current will be? What is this current will be? This current will be 1 plus IC of 0 plus. Okay. Now, if I write the KVL for this, minus 3 plus 4 into 1 plus IC of 0 plus, I'm not writing, plus 1 volt is equal to 0. Right? Minus 3 plus 4 plus IC plus 1 is equal to 0. From this one, IC is equal to minus 5 plus 3 is minus 2. Okay, this is minus 2. Minus 2 is equal to C into minus 10. So from this one, C is equal to 1 by 5. That is equal to 0.2 farads. Option is D. Option is D for Delhi. Right? Yes. So this way, all other subjects will continue. And one thing is very important. It's all about brainstorming, not mugging. Okay. If you mug, that question only you can remember. But if you try with the first principles or fundamentals of engineering, you can do any problem. Okay. All the best. If you have any questions, you can contact us. We started a dedicated module for Coal India Limited examination preparation. Those who are interested, you can join for full module in which all the subjects in very detailed manner we will be covering. Right? Yes. All the best. Any questions? If you have, you can ask. If you have any questions, you can ask. No questions?